All right, so let's practice a little bit with conjugate acid-base pairs. So remember, a conjugate acid is the conjugate acid-base pair, so we just looked at in the previous video. Here was an example where an acid is losing a hydrogen and a base is something that is accepting a hydrogen. So whenever we have an acid-base reaction, there's always a conjugate acid-base pair. So let's just look at some examples. So if I give you a list of acids, I would expect you to be able to write the conjugate base. And if I gave you a base, I would expect you to be able to write the conjugate acid. So again, the difference between an acid and a conjugate base is the loss of a hydrogen. So let's just write some acids over here. Here's HCl, HF, so this is hydrochloric acid, hydrofluoric acid, H2CO3. So if we were to write the conjugate base of each of these, the difference between the acid and the conjugate base is that we are losing a hydrogen ion. So remember, a hydrogen ion, it's an ion, which means it's charged. This is a neutral molecule. If we remove an H+, we are going to get a Cl-. So the charge is also important. We're not just going from HCl to Cl, because this HCl is neutral because it's an H+ and a Cl-. So the conjugate base of hydrochloric acid is the chloride ion. Here, if I have hydrofluoric acid and I lose an H+, the conjugate base is the fluoride ion. So this one is a little tricky. This bicarbonate right here, or the carbonic acid here, is going to lose one hydrogen. It's just going to lose one. So these are called ionizations, and we only ever lose one hydrogen at a time. So if we were to lose one hydrogen here, it would be HCO3 minus 1. So this is one ionization, or losing one hydrogen. Because we still have one hydrogen here, we could go on to lose another hydrogen, but the conjugate base to this acid is HCO3 minus. Here we had in the previous example, this is the ammonium ion, it's NH4 plus. Here the hydrogen is not in the front. There are some examples where the hydrogen is not in the front. Most of the time we call this hydrogen in the front the acidic proton. It's the proton that gets donated. But here is an example where it's not in the front with the ammonium ion. So this becomes NH3, and it was +1. We lost a positively charged hydrogen, so now it's just NH3 and it's neutral. Now let's look at water. Water is H2O. And if we lose one hydrogen, now we're going to have just an oxygen and one hydrogen. And the way that we would write that is OH minus. This is the hydroxide ion. The hydroxide ion is the conjugate base of water. If you wrote HO positive, it would be incorrect as the way that the common way that hydroxide is written. But the major point here is that this water, which is neutral, is losing one hydrogen, H+, and we get OH minus. So let's look at some bases. Let's look at the iodide ion, the bromide ion. These are bases. And let's look at HSO4 minus. So remember, the difference between the base and the conjugate acid is that we are adding a hydrogen ion. So if we add a hydrogen ion, the hydrogen's going to go in the front. It's going to be HI. This is hydroiodic acid, or hydrogen iodide. The hydrogen goes in the front. Here it would be HBr. This is hydrobromic acid, or hydrogen bromide. Here, if we add another hydrogen in the front, instead of having HSO4 minus, we're going to have H2SO4, which is neutral. This is sulfuric acid. Let's look at water. When water acts like a base. So if we add a hydrogen to this, H3O plus, this is the hydronium ion. So maybe we'll name this conjugate acid-base pairs and amphoterism. Amphoterism is when you have a substance that can act like both an acid and a base. Or this is also called amphiprotic. So amphi, the prefix amphi means both, like an amphibian lives in both the water and the land, or somebody that's ambidextrous uses both their left and right hand. Amphiprotic, protic means proton, amphiprotic means that water can act like an acid and lose a hydrogen, or water can act like a base and gain a hydrogen. So this is not a characteristic that is specific to water. There are many other substances that have this property of being able to act like both an acid and a base. When we start talking about buffers, we'll see that buffers all can act like amphiprotic species, where they can donate or gain, they can give or take a hydrogen ion. So I would expect you guys to be able to write the conjugate acid-base pairs from an example of an acid or a base, or be able to identify what the acids and the conjugate base, or the base or the conjugate acids are in a chemical reaction.